What exactly is time? We speak of it, track it, and fear it slipping away. We measure seconds, minutes, and hours, yet when we try to define time itself, it seems to elude our grasp. Is it a dimension like space, something woven into the fabric of reality, or merely an illusion cast by our consciousness? Let's take a journey through the enigmatic nature of time, peeling back layers of science, philosophy, and mystery as we go. The arrow of time. Why does time move forward? One of the greatest puzzles about time is its one-way flow. If you drop a glass, it shatters into pieces. If you record it and play it in reverse, the glass reassembles. But in reality, we never see that reassembly. This forward-moving flow is what physicists call the arrow of time, and it seems unbreakable in everyday life. So, what makes time march relentlessly forward? Much of it, scientists say, boils down to entropy, a measure of disorder. In a closed system, entropy only increases, so the universe as a whole is always moving toward greater chaos. This irreversible trend, described by the second law of thermodynamics, might explain why time feels like a one-way street. But here's the twist: the laws of physics themselves don't actually require time to flow in one direction. The equations work just as well in reverse. Which begs the question, is the arrow of time an illusion? Time and space, two sides of the same coin. In the early 20th century, Albert Einstein revealed something astonishing. Space and time aren't separate entities, they're interwoven into a single, four-dimensional structure called spacetime. This framework, known as the theory of relativity, fundamentally changed how we think about time. Instead of ticking uniformly for everyone, time can stretch, slow, or even appear to stop depending on the observer's speed and gravitational environment. Imagine twin astronauts, one travels on a high-speed mission while the other stays on Earth. When the spacefaring twin returns, they'll have aged less. Time, it turns out, is relative. This phenomenon, called time dilation, has been proven with atomic clocks on satellites, which tick slightly differently from those on the ground. But if time itself can shift and bend, what does that say about our experience of past, present, and future? Past, present, and future, do they all exist at once? Most of us experience time linearly, a sequence of events moving from past to future, with the present as a razor-thin boundary in between. But some theories suggest that all moments might exist simultaneously, like frames on a film reel. Imagine that the entire universe is a film, and each frame contains a different moment in time. We, the observers, can only see one frame at a time, giving us the illusion of time passing. Physicist Julian Barber has proposed that time might be nothing more than a series of nows. If he's correct, the universe is a collection of frozen moments, each existing in a kind of timeless tableau. We merely experience these snapshots in sequence, creating the perception of a continuous flow. Could it be that the past and future are already out there, forever fixed, waiting to be experienced? The mystery of time travel, science fiction or possibility? What if we could break free from the arrow of time? The concept of time travel has fascinated us for centuries, appearing in stories, myths, and dreams. But is it physically possible? Einstein's equations seem to allow for time travel, but with one small hitch: we'd need a wormhole or an area of spacetime that connects two distant points, potentially two different times. Theoretical physicists have even toyed with the idea of closed time-like curves, which would allow an object to loop back and visit the past. However, even if we could build such a device, time travel is fraught with paradoxes. For example, if you go back in time and prevent your grandparents from meeting, would you cease to exist? Or, as some propose, could you merely create a new timeline, splintering off into an alternate universe? Time and consciousness, the role of the mind. As strange as it sounds, our perception of time may be shaped by our minds as much as by physics. Neuroscientists suggest that our brains don't simply see time flowing, they construct it. Our memories give us a sense of the past, while our imagination allows us to envision the future. To some philosophers, like Immanuel Kant, time is a mental construct, a framework that helps us make sense of the world. Moreover, recent studies suggest our brains experience time differently in various states. Moments of danger or joy can feel longer or shorter than clock time. So, is time a physical entity out there in the cosmos, or is it inextricably bound to our experience and perception? The ultimate question, is time an illusion? Some modern physicists, like Carlo Rovelli, suggest that time might not even exist in the way we think it does. According to quantum mechanics, on the smallest scales of reality, time appears to dissolve. Subatomic particles seem to ignore time altogether, moving in ways that suggest time is not fundamental to their behavior. In Ravelli's view, time emerges only as a result of our limited perception, a kind of useful illusion that helps us make sense of a timeless quantum world. If time is truly an illusion, this would mean that all our past moments, our hopes for the future, our very sense of aging and decay, are constructs, not features of an objective reality. But what, then, is the nature of a reality beyond time? In the end, the nature of time remains one of the most profound and enduring mysteries of existence. Whether it's an unstoppable arrow, a dimension woven with space, or a mere illusion conjured by our minds, time is essential to our experience of reality. And as we continue to explore the depths of physics and consciousness, the true nature of time may yet reveal itself, unraveling the secrets of our universe. Or perhaps, just perhaps, we'll discover that time itself is a mystery we were never meant to fully solve. Who knows what lies ahead? Perhaps one day, we'll learn to navigate time as we do space, wandering through memories, exploring the distant future, or lingering eternally in the present. Until then, time remains our companion, our teacher, and our greatest mystery.